Hi, this is Dr. Anita Shah from WA Department of Region Education and Research Foundation Group of Institutions. I would like to speak about the two-transistor model of Scr. So let's begin. Two-transistor model of Scr. We know that Scr is a four-layer device where P and Pn are the layers with alternative Pn layers, and the junctions are J1, J2 and J3, and the three terminals are anode, cathode and the gate. So we know it is a PN thyristor. Now in this figure we see that there is a black bold line marked over here. If we imagine that we bisect this thyristor from this region, we have two parts. The first part represents one transistor and the second part represents another transistor. The first transistor is a PNP device and the second is an NPN transistor. The first transistor PNP is formed around the junctions J1 and J2, and the second NPN is formed around the junctions J2 and J3. These two transistors can be represented like this, where IA is the anode current and IK is the cathode current and IG is the gate current. Now we know that IC is the collector current, IE is the emitter current, ICBO is the forward leakage current, and alpha is the common base forward current gain. So keeping all these things in mind, we know what is the relationship between the collector current and the base current of a transistor. That is, collector current is equal to beta into IB, where IB is the base current and beta is the common emitter forward current gain. Considering this figure for transistor T1, this is a first transistor, it is named as T1. We see that IC1 is the collector current, IB1 is the base current and IE1 is the emitter current, which is also the anode current. So we can write IC1 is equal to alpha 1 into IA plus ICBO1. And similarly for the transistor T2, for this second transistor T2, we can write IC2 is equal to alpha 2 into IK plus ICBO2. Again we know that IC2 is equal to beta 2 into IB2. Now we know that for the two transistor model we can get the anode current, that is IA. If we consider this transistor, we can see that IA is equal to IC1 plus IB1. Again, this IB1, which is the base current of the transistor T1, is also the collector current of the transistor T2. So IB1 is equal to IC2. So by following KCL rule, we can write IA is equal to IC1 plus IC2. Substituting the values from the previous equation in this equation, we can write that IA is equal to alpha 1 IA plus ICBO1. This is our IC1 plus alpha 2 IK plus ICBO2. This is our IC2 part. Now, from the first figure, if we remember, we have seen that the thyristor is a PNPN device which is having three terminals, anode, cathode and the gate. So we can say that IK is equal to IA plus IG. This is anode current plus the gate current. So we can also substitute the values in this equation and find that IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 into IA plus IG, which was IK in the previous equation. We have replaced IK by IA plus IG plus ICBO2. So the ultimate equation for IA becomes alpha 2 IG plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. We can say from this equation that if we are increasing the value of alpha 1 plus alpha 2, then corresponding anode current will also increase. But now the question arises, how will we increase the value of alpha 1 plus alpha 2? If we consider that we are applying the gate current IG only, then it is also the base current of transistor T2, and again IE2, that is the emitter current of transistor T2, is also the cathode current. Hence we can write alpha 2 is equal to ICBO1 by Ig. Now we can write IC2 is equal to beta 2 into IB2, and we can replace beta IB2 by Ig. So IC2 is equal to beta 2 into Ig. Again, IC2 is nothing but it is the base current of T1. So as we know, IB1 is equal to IC2. So this will cause the flow of collector current as IC1 is equal to beta 1 into IB1. We can then write beta 1 into beta 2 into Ig as IB1 is equal to IC2, and from the previous equation, this equation, we know IC2 is equal to beta 2 into Ig. So if we put the value of IC2 in this equation, we will get beta 1 beta 2 into Ig. IC1 and IB1 together, it leads to the establishment of IA, and again IA is equal to IC1 plus IB1. In this way, alpha 1 increases. Now if we consider the new base current of T2, which is equal to Ig plus IC1, that is IC1 is equal to beta 1 into beta 2 into Ig, we know from the previous equations. So Ig plus IC1 becomes 1 plus beta 1 beta 2 whole into Ig, which will lead to increase in the emitter current. Ik is equal to Ig plus IC1. Now as a result, alpha 2 also increases, and this in turn further increases our IC2. So now IC2 becomes beta 2 into 1 plus beta 1 beta 2 into Ig. As IB1 is equal to IC2, this in turn again increases our alpha 1. So we can say that this is a continuous positive feedback which affects also the increase in alpha 1 plus alpha 2 towards unity, and anode current tends to flow at a very large value. So even this is a continuous regeneration process. After this has been achieved, we can remove the gate current, then also regeneration will be continued. So this value of current which is increasing can be controlled by an external load impedance. So this was all about the true transistor model of SCR. Thank you.